Hello students, today we will see the velocity analysis of four-link mechanism using instantaneous center method with application of angular velocity ratio theorem. For this we take up a problem of four-link mechanism. A four-link mechanism is shown in the figure. The angular velocity of the link AB is given and we need to locate the instantaneous centers of the given mechanism, and we need to determine the angular velocity of the link CD and the angular velocity of the link BC. Before moving ahead with the velocity analysis, let us do a fast revision of what we learned in the last video. So we had this four-link mechanism. So as per the formula, we will have 6 number of instantaneous centers, and they are I12, I13, I14, I23, I24 and I34. So as we learned in the last video that these can be located either by inspection or by the application of Kennedy's theorem. So we'll see how. So link 1 and 2 is pivoted at point A, so it will be the instantaneous center I12. Similarly, link D is moving about point D. Link 4 is moving about point D and it is pivoted at point D, so I14 will be at point D. Similarly, link 2 and 3 are pivoted at B, so they will have the instantaneous center as I23. Similarly, link 3 and 4 will have the instantaneous center I34 at point C. Now, with the application of Kennedy's theorem, we'll first plot all the 4 points 1, 2, 3, 4 as the 4 links. Point 1, point 2, point 3, point 4 we have plotted, and we'll join the sides of the polygon to get the instantaneous centers that we have already obtained by inspection. Now to obtain the instantaneous center I13, we'll join the diagonal I13. This will divide the polygon into two triangles, I143 and 123. So 143 will have the sides as I14 and I34 as the instantaneous center, and similarly the triangle 123 will have the sides I12 and I23 as the instantaneous center. So to obtain I13, we'll join the lines joining I14 and I34 and I12 and I23. So I14 and I34 will be extended and I12 and I23 will be extended like this. So we'll obtain the point I13 as the instantaneous center. Similarly, to obtain I24, we'll join the diagonal I24, 2 and 4, and this will give us the triangles 2, 3, 4 and 1, 4, 3. So 2, 3, 4 will have the instantaneous center I23 and I34 as the sides, and triangle 1, 2, 4 will have I12 and I14 as the sides of the triangle. So we'll join the line I12 and I14, and we'll join the line I23 and I34 as follows. This is I12 and I14 extended, and similarly this is I23 and I34 extended. They will intersect at the point I24. So this is how we obtain all the 6 instantaneous centers. Once we have determined all the 6 relative instantaneous centers, we are in the position to carry out the velocity analysis. Before moving ahead with the velocity analysis, let's first see the angular velocity ratio theorem. So when the angular velocity of the link, say second link, is known, and it is required to find the angular velocity of the other link, say third link, then we first locate their common I center. So in this case, I23 will be the common I center that we have already located. Then according to the angular velocity ratio theorem, the velocity of I center I23 relative to the fixed link, it is the first link here, is the same whether the I center is considered to be on second link or on the third link. It means we'll take the relative velocity of I23 with the first link, or the velocity of I23 relative to the fixed link will be same whether we consider I23 on second link or on third link. In both the cases the velocity will be same. So moving ahead, to carry out the velocity analysis, let's see this figure. So using this, we'll do the velocity analysis. as follows. For velocity analysis, let's say the angular velocity of the input link, say link 2, is given as omega 2. And our task is to determine the angular velocity of the other two links BC and CD. That is link 3 and link 4. So we need to find out omega 3 and omega 4. To do that, we carry out the velocity analysis as follows. For velocity analysis, let's say the angular velocity of the input link, say link 2, is given as omega 2, and our task is to determine the angular velocity of the other two links, that is the link BC and link CD, that is we need to find out omega 3 and omega 4. To do that, we carry out the velocity analysis as follows. We are given omega 2 and we need to find, suppose, first omega 3. So if omega 2 is given, then we can find the velocity of point B or I23. That is VB, which is equal to V23, will be equal to omega 2 or omega AB into B minus A. That means this distance. Point B or I23 is rotating with respect to point A. So this can be written as VB is equal to omega AB, that is omega 2 into I23 minus I23 minus I12. That means this distance AB. B happens to be the relative instantaneous center. That means if we consider this point B to be a point on link 2, whatever its velocity be, its velocity we have already calculated as this much. And if we consider it to be on the link 3, then it will have the same velocity. This is according to the definition of the instantaneous center. Now let us take the point B or I23 on the link 3. The link 3 is rotating at this instant about the point I3. I13 is the instantaneous. So the velocity of point B, if we consider it to be a point on link 3 which is rotating with the angular velocity omega 3 about the point I13, is given by VB or V23 is again equal to omega 3 or omega BC into distance B minus I13, distance of that can also be written as VBC. V23 is equal to omega BC into I23 minus I13, this distance. So knowing these two as equal, we can further get omega AB upon omega BC, that is omega 2 upon omega 3 is equal to I23 minus I13 is equal divided by I23 minus I12. So this is how we can determine omega 3. Now to determine the output angular velocity omega 4 of link 4, we consider the point I24, which we have already located. Now I24 is a point whose velocity will be same whether we consider it to be a point on body 2 or on body 4. If we consider I24 to be a point on body 2 which is rotating about A or I12, so the velocity V24 will be equal to omega 2 into I24 minus A. This can be written as omega 2 into I24 minus I12, as the link 2 is rotating about the center A or I12. Now let us consider the same point I24 as a point on body 4. Then we must get the same velocity. So we can write as V24 is equal to omega 4 into I24 minus D or I14, because the link 4 is rotating about point I14 or D. We can further write this as V24 is equal to omega 4 into I24 minus I14, the center of rotation of link 4. As we know, these two velocities will be equal, so we get omega 2 upon omega 4 as I24 minus I14 divided by I24 minus I12. So this is what we mean by velocity analysis of a mechanism. If the input angular velocity is given, we can obtain the relative instantaneous centers and use them judiciously to determine the known quantities, to determine the unknown quantities. Now, to make this more clear that this I center I24 is lying on 2 also and is lying on 4 also, let us consider a mechanism shown here. This is a 4-link mechanism. As we see here, there is a fixed link 1. Then there are 3 moving links. Link 2, then link 3 is the coupler, and link 4 is the output link. So this is A, B, C, D according to our previously taken notations, and also these are the instantaneous centers I12, I23, I34 and I14 respectively, as we have determined them by inspection. Now, applying Kennedy's theorem, we have seen that I13 is located at the point of intersection of these two lines. The line extended, a line joining I12 and I23, and the line joining I14 and I34. Similarly, I24 is located at the point of intersection of these two lines, that is this one and this one, that is the line joining I12 and I14 and the line joining I23 and I34. Now we have these points I13 and I24 as we previously determined them. Now if we move this linkage around this given configuration, and as this point I3 is now, if we move this linkage around this configuration, as this is point I3, that is the linkage or the link 3 is instantaneously rotating about this point I3. So this point does not move. This point has 0 velocity, as we see here. As we are moving, this point is hardly moving. This point is stationary. It is having 0 velocity. I13 is having 0 velocity. Then again see this. As these links are moving, all the other points are moving, but I13 is stationary, nearly stationary. It is not moving. So we see now, to see the significance of I24, let us consider I24 is coincident point on link 2 and link 4. That is the point on link 2 and exactly just below the point, below this point, a point on link 4. these 2 points on link 2 and 4 at this instant have same velocity, and that is why we call it as I24, an instantaneous center of 2 and 4. Around this configuration, these 2 points move with the same velocity, as we can see here. These 2 points are moving with the same velocity. You can't see 2 different points, there's only single point, so they are moving with the same velocity. So this is how you can understand how this I24 is lying on 2 and 4 and I13 is lying 3. Now further, we'll generalize the angular velocity ratio theorem as follows. We already determined omega 3 by using omega 4 by using omega 2 upon omega 4 is equal to I24 minus I14 divided by I24 minus I12. And similarly omega 3 by using omega 2 divided by omega 3 is equal to I23 minus I13 divided by I23 minus I12. So this is a simple case. Suppose we have n number of links, there are more number of links. Then how to write this equation for any link? So for that we have this general formula as omega n upon omega m is equal to I nm minus I1m divided by I nm minus I1n. As we are seeing the velocity of this any instantaneous center, whether it is on link 2 or it is on link 4, or maybe if we are considering I13, whether it may be on link 2 or link 3, then we are always finding out the velocity of the instantaneous center with respect to the fixed link, that is taken as 1. You are considering that the fixed link is always taken as 1. So we can see from this generalized formula, if suppose n is 2 and m is 4, then we will have 2 here and 2 here, and m is 4, so we will have 4 here, 4 here, then we have 1 and 1 here, then we see that m goes here and n comes here, that is 2 goes here and 4 is here. So this is how we can write this angular velocity ratio for any link as per the given problem. So now I suppose you have understood how to use the instantaneous center method of velocity analysis. So you can now solve few more examples from the book, and in case of any difficulty you can contact me. Thank you.